All right, today we are talking about section 8.3. Remember, tomorrow we will do some review. Thursday we will have an in-class assignment. Those of you that are not going to be here, you will need to check Google Classroom. Friday we are going to take a quiz. Today is highly related to what we were doing yesterday. Yesterday we talked about certain properties that a parallelogram has. Today we are going to talk about how to prove or show that a quadrilateral is a parallelogram. All right, first up, what congruence postulate shows that triangle ABE is congruent to triangle CDE? So triangle ABE is this top triangle, CDE is the bottom triangle. So if we were in a proof, how would we say that we know that these two triangles are congruent? So we would use vertical angles, but then after we use our vertical angles, what would actually go next to that, Taylor? Side angle, side. Very good. So side angle, side shows that these two triangles are congruent to each other. If we were writing the proof, we would have to use our vertical angles being congruent there. Questions about side angle, side? Okay. Number 2, if angle E is congruent to angle G, find the measure of angle E. So they did not tell us that this is a parallelogram, so we can't really use that. We do know that it is a quadrilateral because it has 4 sides. So we know all the angles all together should add up to what? 360. So we should start by subtracting off the angles that we do know. If we subtract off the angles we do know, what do we get? 236. And what do you think we need to do to that number? Very good. We need to divide that by 2 to split it between the two angles that are left over. If they're going to be congruent, we should split this evenly between them. And what would we get? Okay, 118 for angle E. It would be the same for angle G. Questions, concerns about our warm-ups? Need more time? Okay, moving on. Oop, too fast. Here we go. All right, we are given some information. We are asked to prove that ABCD is a parallelogram. Remember, that's our little symbol for parallelogram. So it's been a while, but we should remember how this works. We need statements and reasons. Statements, reasons. Our first statement. BC is parallel to DA and BC is congruent to DA. How did we know that? That information was given to us. They marked the congruence on the diagram for us. They didn't put the parallel triangles. We could add those. We don't have to, but there they are. All right, so I will give you a helpful hint that in order to show that ABCD is a parallelogram, we're going to end up using the definition of parallelogram. What does the definition state? What's the definition of a parallelogram? The what? Not equal. both pairs of parallel sides are, or both opposite sides are parallel. Okay, so we need both pairs of opposite sides to be parallel. We've got one of them. We need to show that CD and BA are parallel. Okay, that's going to get us to here. But we're not ready for that yet. So in order to get there, you're going to need to show that these two triangles, ABC and CDA, are congruent to each other. So that's our first goal, is to show these two triangles are congruent, and then we'll be able to work our way towards that definition. So if we're trying to show those triangles congruent, what's something that would help me out?
Proving that C is congruent to C.
Okay. By what property?
Was it reflexive?
Good. So AC is congruent to AC by the reflexive property. That's going to help get me closer to having congruent triangles. So you could put 2 tick marks on it. Some people like to put an X on it. Whatever you want to mark it with, it's congruent to itself. Okay, now the next part hinges on the fact that we do have parallel lines. We were already given those. So we have these parallel lines, and they are cut by a transversal. So now we need to be looking for a pair of congruent angles. Micah, what do you think? Those are not part of this transversal. Sort of, but C and A, there are 3 different angles at both C and A. So we got to be a little more specific. Very good. So we could say that angle BCA, which is this one up here, is congruent to angle DAC, which is the one down here. And how would we know that those are congruent? What's their relationship with those parallel lines? Very good. They are alternate interior angles. So alternate interior angles on parallel lines are congruent. Okay, bringing some knowledge back from first semester. Do we have questions about getting to that part? Okay, now do we have enough information to say those 2 triangles are congruent? Yes, by what? By side angle side. So make sure you're careful about how you name those triangles. So we could call them triangle BCA congruent to triangle DAC. Kind of keeping the same order that we did those angles in makes it a little easier to name them. So by side angle side, those triangles are congruent. Okay, I need to erase a little bit off of my diagram. I'll put some of those marks back up there. So we had these were parallel. These were congruent. That was congruent to itself. All right. So I'll go ahead and give you a little helpful hint that we now want to talk about these 2 angles being congruent to each other. How would I name those angles? DCA is one of them. DCA is congruent to BAC. Does anybody know why I was able to make that statement? Taylor?
C
Very good. Corresponding parts of congruent triangles are congruent, also known as CPCTC. When we do that, we are able to shift our focus to these other lines, BA and CD. We're still going to think about the same transversal cutting them. But again, what's the relationship between those angles that we put two arcs in? They're alternate interior angles. And if alternate interior angles are congruent, which we just said they were, then what does that mean about AB and CD? They're parallel. So this allows us to say that AB is parallel to CD. Our reason still has to do with the fact that alternate interior angles were congruent. Technically, this would be the converse of that. We're just using it in the other direction. Questions about that?
Do we have to write converse on like
No, if you weren't to forget the word converse, I would not mark it off. That's fine. Other questions at this point, Micah?
So basically, why do we just have to write like that everything's congruent to each other?
Well, we're not done just yet. Because we haven't made our proof statement yet, right? So we've shown now that these are parallel lines. So I'll give them each 2 triangles. Are we ready for our proof statement? Yes, we're ready for it because the definition of a parallelogram is that you have 2 pairs of opposite sides parallel. And now we have that. They gave us one, we just showed another one. So now we can say that ABCD is a parallelogram. Anybody think they know what the reason would be? Definition of a parallelogram. Definition of a parallelogram. Now I have some good news for you. We're about to learn a bunch of theorems that would let us skip a lot of that. Basically all of it, actually. Huh?
So that means that this idea is like no proofs if we're skipping all that.
I mean, if you were to remember your theorems, you could shorten this up to being 2 steps instead of 7 steps. Unless I ask you to prove a theorem, then you'd need to do all these steps. We'll see how it goes. Questions before we learn all the theorems that make our life a lot better? Okay. For the most part, these theorems have to do with what we talked about yesterday, but in reverse. There's one of them that's a little bit different that has to do with the proof we just did. First one, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. That's the converse of something we talked about yesterday. Yesterday we said if it was a parallelogram, then opposite sides were congruent. See how this is just backwards? Okay, so what do you think the next one is? If both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. The next one is not something we talked about yesterday. However, it was the situation we just had in that proof. We just proved theorem 8.9. If one pair of opposite sides are congruent and parallel, at the same time, which that was the given information on that proof we just did. One pair was both congruent and parallel, then it's going to be a parallelogram. We just proved why. If the diagonals of a quadrilateral, anyone remember what they do from yesterday? Starts with a B. Bisect. If they bisect each other, the diagonals, then the quadrilateral is a parallelogram. So a lot of this is just taking what we had done yesterday and switching it around. The only exception being this one here, both congruent and parallel. Questions, concerns, need more time with these theorems? Okay? In a quadrilateral, GHJK, we're given some of our angle measures. We are asked to find the last angle measure. If all they tell us right now is that it's a quadrilateral, what do we have to do to figure this out? Okay, make sure they all add up to 360. So far, they have not told us that it's a parallelogram. We haven't proven it to be a parallelogram. So if all we know is that it's a quadrilateral, then all we know is that we got to start with 360 and subtract off all the ones that they told us. Okay, if you would rather add up all three of these first and then do one subtraction, that's fine. Either way, what do we get for the measure of angle K? Okay, we do get 125 degrees. So what theorem could we use to show that this is a parallelogram?
Yeah.
8.7 talked about the sides.
8.8.
Okay, 8.8 talked about the angles. So I wouldn't rely on referring to it as theorem 8.8. I would sum it up and say both pairs of opposite, what are we talking about here? Angles are congruent. Yes.
For the proof, will we have to memorize the theorems, or will we just write it?
You would write some sort of summary of it. Okay, your textbook refers to that as theorem 8.8, but in other textbooks where they go in a different order and it's in a different chapter, it wouldn't be called 8.8. So like if you were to go to some math professor at a college and talk about theorem 8.8, that would mean absolutely nothing to them. So instead of memorizing those numbers, I want you to know what it means. Questions, concerns before we keep going? Okay. On we go. For what value of x is RSTU a parallelogram? Explain. Ooh, that explain word. Okay, what needs to be true about our diagonals that they drew in if this is going to be a parallelogram? They bisect each other. Now, they already showed that this point where they intersect is the midpoint of one of the diagonals, but not the other. So how are we going to figure out this value of x that we would want? Okay, set them equal to each other. We would want these little pieces to be congruent. So 8x minus 32 is equal to 4x. To solve it, what are you going to do? Okay, you could go a couple different ways. One way would be to subtract the 8x. What would that leave us with? Okay, negative 32 equals negative 4x, and then what would we do to both sides? Divide x equals 8. Now, we found that value, we still need to explain. How would you explain to me why this would be correct? Kara?
If the diagonal bisects each other, it is parallelogram.
Okay, so you could say simply that diagonals must bisect each other in a parallelogram. Something along those lines. It doesn't have to be worded exactly that way, but it should be something similar to that. You need to get used to explaining yourself. That's something that comes up a lot in this chapter. Questions, concerns before we move on? Okay, on we go. In the diagram, A, B, and DC represent adjustable supports of a basketball hoop. Explain why AD is always parallel to BC. Adriana?
They're both opposite sides in quadrant.
Can you say that one more time a little louder?
Both opposite sides of a quadrant are parallel.
Okay, so I think that's a good place to start. So in the diagram, they show us that both pairs of opposite sides are congruent, which means that this is definitely a what? Parallelogram. So ABCD is a parallelogram. And what do we know about parallelograms by their definition? We already talked about them being congruent. The definition. Go back to the definition, not a theorem. Kara?
That AD and BC are parallel.
But yeah, opposite sides are parallel. In a parallelogram, opposite sides are parallel. So AD and BC are opposite sides. They must be parallel. So what they mean by that is that even if these supports, bless you, get adjusted, okay, we could move the hoop up or down. Looks like probably down here. Okay, if we move it up or down, AD and BC are still going to be parallel to each other because the lengths of these don't change. It's just getting shifted. Questions, concerns? Are we getting the feel for explaining ourselves on these? Okay. All right, show that quadrilateral KLMN is a parallelogram with the given vertices using two different methods. So let's start by plotting that quadrilateral. Yeah. Yes.
So let's say, since we have to use 50, let's if we split that down the middle from L to N into a triangle. Since that would be like, if we use the reflexive property to make this a ruler, would K and N be congruent angles because they have the same side?
K and N. So you're wanting to show the triangles congruent?
Yeah, that's what
You could do that, but I think that might be more work than you're thinking it'll be. So yes, we could use reflexive property, but then you're going to have to find the distances. Well, we're probably going to have to find the distances anyway. But you could do that. I just don't know that that'll be necessary. Does that make sense? Okay. All right. So Kara leads us into this problem kind of nicely, though. There are a couple different things we could do in order to show that this is a parallelogram. One way would be to go back to the definition, which would say that opposite sides are parallel. Does anybody know what we would need to find to show that these opposite sides are parallel? Oh, Sean's got it. To show that lines are parallel, we need to know their slopes. So that's one way to do it. We could pull in the diagonals. I don't know that that would be a great way of doing it. I'm not saying we couldn't, but that might be a little bit tricky. So one way would be to show opposite sides are parallel, in which case we need to know slopes. So that's going to be the first method I would recommend, because finding slope isn't all that bad. So let's start with KL, the slope or M of KL. How do we find slope between 2 points? To find the slope, we need to take y2 minus y1 over x2 minus x1. So if we're talking about KL, what should go in my numerator? 2 minus 4 over 2 minus 4. Okay. 2 minus 4 is negative 2, which means this simplifies to be 1. Okay, what side is opposite KL? MN, so I would say the next slope we should find is MN. If these lines are going to be parallel, what needs to be true about their slopes? They gotta have the same slope. Okay, so for MN, what's going in our numerator? If you start with 0, then you should put what after it? Plus 2. We're subtracting a negative, so it should be 0 plus 2. If we started with 0 on top, then on the bottom we should start with 6 minus 4. Okay, 0 plus 2 is 2. 6 minus 4 reduces to be 1. So we've shown that KL and MN are parallel. We could put little parallel triangles on them. We're halfway there. We still need to show that the other two sides, so KN and ML, are also parallel. So we've got 2 more slopes to find. So let's do KN. The slope of KN, what goes on top? So if you start with 2 from K, what should go after it? Plus 2 minus a negative would be plus. Okay, so if we started with K on the top, we got to start with K on the bottom. So that would be 2 minus 4. Now, if you do these reversed, like you did negative 2 minus 2, and then 4 minus 2, that's fine. You should end up with the same thing either way. What does this slope reduce to? Negative 2. And last, we need to find the slope of ML. What are we putting on top? Zero minus 4, and on bottom would go 6 minus 4. 0 minus 4 is Negative 4 over 2 reduces to be negative 2. So those slopes are the same. We've shown those to be parallel. Okay, so we've shown that this is a parallelogram one way by showing that opposite sides are parallel using our slopes. Do we have questions about that method? Okay, anybody have an idea about another method they would like to use? We talked about the fact that diagonals bisect each other would work, but I think that's going to take quite a bit of work to show. Atea? We could use distance formula. There are a couple different ways we could use distance formula. We could find the distance of all four sides, right? Because we would want to show that opposite sides are congruent. But if you flip over to the back where we went through all those, or sorry, the front where we went through all those theorems, there was one theorem that said something about if you know one pair of sides is both parallel and congruent, that would be enough. And we've already shown parallel. So if we could just get one of these pairs of sides to be congruent, that would be enough. Does that make sense? So that way we would only have to do distance formula twice instead of 4 times. So I would say our next method would be one pair of sides both parallel and congruent. So this is my second method. I'll try to box this one off. Here was my first one. I'm going to try to show the second one down here, or at least start it. Which pair of sides do you want to use? KL and MN, okay. So you don't necessarily have to, but you could make a little note. The slope of KL was equal to the slope of MN from our first method over here. So you could just draw an arrow to that box. So that way we're not showing all that work a second time. We already found that their slopes were the same, therefore they are parallel. Now we just need to show that they are congruent, so we need to use our distance formula. Let's start with KL. Remember, distance formula is the one with the really long square root. So underneath that radical, what are we doing? So x minus x, so we could do 2 minus 4 squared plus 2 minus 4 also squared. Okay, 2 minus 4 is negative 2. When you square it, you get 4. So we end up with 4 plus 4, which is 8. Now we could simplify this further and make it into 2 root 2 or use a calculator to get a decimal. We don't really need to because we just need to be able to show that these are congruent or have the same distance. So let's move on to MN. For MN, what's going in for my x minus x? 6 minus 4 squared plus, very good, 0 plus 2 squared. 6 minus 4 is, careful, 2. Either way though, when you square it, it becomes 4. 0 plus 2 is 2, and you square it, you get 4. So this is also the square root of 8, which would simplify to 2 root 2. But either way, now we've shown that these are also congruent to each other. So by that theorem from the front, we have one pair of sides that's both parallel and congruent. Therefore, this is a parallelogram. Now, if you forget about this one and you do your distance formula 2 more times, that's fine. You could show that both pairs of opposite sides are congruent. That would work. Nothing wrong with it. Questions, concerns? Need more time? Warm fuzzies? Cold pricklies? Okay, so this last slide, you don't necessarily need to write this down, but let's talk about it. How can we prove or show a quadrilateral is a parallelogram? Both pairs of opposite sides are congruent. Same for the angles. Both, I guess I don't need to shorten that. Both pairs, opposite sides congruent. Okay, both pairs, opposite angles congruent. That's 2 of them. Okay, one pair, opposite sides congruent and parallel. Okay, diagonals bisect each other. We're missing one big way. Anybody know the last one? Has to do with both pairs of opposite sides. Taylor? Parallel goes back to the definition. That's another way to show it. So both pairs of opposite sides are parallel would be that 5th way. You need to know these 5 ways. Essential. So if you need to copy them down into your notes, I would do that.